Hello, in this video I'll be explaining the derivation of the triple product rule. So to start, say we have a function z equals f of x comma y. Now what we're going to do is we're going to take the total differential of this function. So that would give us dz equals partial z over partial x times dx plus partial z over partial y times dy. So suppose we move along a curve dz equals 0. In that case, we can basically ignore the z value and just look at the xy plane. So if we do that, we end up with a separate function dy equals partial y over partial x times dx. And what we're going to do is we're going to substitute the second equation into our first equation for dy. So then, and we set dz equal to 0 earlier, so we would get 0 equals partial z over partial x times dx plus partial z over partial y times partial y over partial x times dx. So now we can just move things around and cancel things. So simplifying, we would get partial z over partial x dx equals negative partial z over partial y times partial y over partial x dx, and then we cancel these out. So then rearranging things more, we can shift the things on the right to the left. So if we do that, we end up with the equation partial x over partial y times partial y over partial z times partial z over partial x equals negative 1. So this equation over here is our first equation of our triple product rule. To get our second equation, all you have to do is basically divide this part over to the right. So that would give us partial x over partial y equals negative. So we've got partial z over partial y all over partial z over partial x. So this part is just our second equation of our triple product rule. There are other ways of deriving the triple product rule, but this is just one of them. So one significant thing I'd like to point out about this equation, though, is the negative sign right here. So why does this matter and why is it useful? So if we, okay, wait, let me just erase this. Okay. Great. So if we go back to our f of x, y, z equation, so suppose we set this to 0, and let's define x as a function of y and z, and we'll differentiate with respect to y. So if we do that, we get partial f over partial x times partial x over partial y plus partial f over partial y, and this gives us 0. So if we just subtract this part over and we divide by this, we would end up with partial x over partial y equals negative partial f over partial y over partial f over partial x. So if we look at this equation over here, partial x, partial y, this is one component of our triple product rule. So if you did the same thing we just did here with respect to the other two variables, you would get two more functions and all of them would have this negative sign. They will all look like this. So if you multiply these three equations together, then you would get a negative times a negative times a negative, which would give you a negative. So hence the negative 1 in our triple product rule. So using the same principle, if we were to look at more than 3 variables, so let's say we looked at 4 variables, the corresponding triple product rule would end up looking something like, so partial x over partial y times partial y over partial z times partial z over partial w times partial w over partial x. And this would give us a positive 1. So because each of these is negative, so we've got 4 negatives multiplied together, and that would give us a positive 1. So this same thing can basically be applied further. And thank you for listening.